Okay, everyone, break is over. Thank you. My name is Patrick. I'm fucking nervous, and this is a talk about a proposal for an open and democratic design rule file format. As there will be no demo in the end, I have some time left, and first of all, I want to thank you to Gerbv for this excellent organization here. You know, guys, there was some discussion in front of the EDA dev room about how to name it, and I'm glad that we find this way. And yeah, thank you for the organization. I hope there will be a dev room next year too, because I pretty much like. Okay, back to the topic. It's about design rule formats, and the reason I started about this is that I believe design rules right now are really, really limited. I have two reasons for this. The first one is that it's completely limited to the printed circuit board. So everything in these design rule formats is always about track width, track clearance to whatever. It's always about the copper, about the solder mask, maybe about the paste layer, but it's always limited to the PCB. But as you guys know, assembling electronic component is much more than a PCB. It's about making the correct stencil. It's about how to place all the components. It's how to actually maybe put the PCB into the SMD line. So this is which all should be covered in the design rule format. And the second reason, what I don't like about the current state of design rules is that they always talk about a lower limit. So for example, if you download design rule files for Eagle, they tell you don't go below, let's say, 0.1 millimeters in track width. So what I've seen is that some PCB engineers draw the whole fucking board with 0.1 millimeters track width. So I asked them, why do you do that? Your board is like 100 by 80 millimeters. Because they tell me, you allowed us to do so. Say, that's the minimum of it. Please don't go below. But if you are able to maybe draw the tracks a little bit wider, why don't you do that? And the reason is not because I told you, but there should be some kind of a window. Something like, don't go below this limit, but if possible, please stay above. Because it's not just about finding a way on how to maybe manufacture a board, it's on finding a way that every PCB will correctly manufacture it. So to sum up, my opinion, design rules are made to simplify communication. It's always about communication from the manufacturer, from the assembly factory, from the stencil producer, to us as engineers. So the design rule file is something you get, in this example, from the PCB manufacturer, and they tell you how to design your design. And I guess that's really important, because, second point, it really lowers the risk of faulty productions. So the first thing when I see faulty PCBs is I check the design rules and see if it's somehow violated. And what most PCB manufacturers don't tell you is that they overproduce. So if you order like 50 pieces of your PCB and they notice that maybe half of the production is faulty, they just produce 100 and send you 50 because the other 50 are just broken. They don't tell you. And then if you go into serious manufacturing, you order like 1,000, and then they're gonna tell you that, hey, I'm really sorry, but yeah, I produced the 50 pieces, but actually I produced 100, and we can't do it that way for the large series. And this is something which is not in the design rules right now. Some things which bother me is for some EDA applications, there is not even a file format. So talking to the KiCad guys around here, if you do design rules in KiCad, you have to type them in by yourself. So you get some kind of PDF from your PCB manufacturer, which tells you about the limits, and then you type them into KiCad. And this is something I really like about Eagle, that you can just download the file and insert them into your drawing, and then it's done. So I have no clue. Maybe I can ask it later why KiCad does not have anything like this. Maybe this is a chance to change that. And one thing which is really important to me is that right now it's only about PCB manufacturing. So nothing about assembly, nothing about maybe sourcing of parts. So why don't the design rule file tell me, hey, if you want to assemble this project within the next 2 years, you have to check end of life of your parts. That's a design rule too. So what does that lead to? Communication. So whenever you try to produce electronic components in a series, you know these phone calls between you and the assembly factory. Something like, hey, there are a few parts which I'm not able to pick and place. Or, hey, there is a part which is too close to the edge of the PCB. It's actually covered in my SMT line. I'm not able to produce this. Or, hey, the stencil you delivered to me actually does not fit because the shrink of the pads is not existent at all. Please shrink the pads of like 15%. So this is everything which comes together later when you assemble the PCBs, which is not covered at all. And this is something like which happens when you are actually finished with your design. Because as soon as you finished, you give it off to the assembly factory, and then you notice this is wrong, this is wrong, this is wrong. I want to know that upfront, not later in the assembly. Something more theoretically. So we have us as the engineer drawing our electronic components. Then there is the manufacturer. Manufacturer in this case here can be PCB manufacturer, assembly factory, or even part distribution. This is something which is necessary in every electronic design. And there are software and services. Software and services in this case are the parties which actually check this. So here are the requirements over at the manufacturers. We have the engineer, which we have to fullify this, and we have the software and services, such as KiCad, which should check on this. So, and in the middle, which connects all these parties, is the open design rule format. Something really boilerplate stuff, which maybe applies for all file formats, but I just want to rephrase it. It's open commonly accepted, woo, yeah. Extensible and flexible, and backwards compatible. So nothing special, I just want to put it on the screen. Let's get a little bit more into detail. We talked about file formats previously, so I heard like S expressions, JSON. I have one more because I'm more the Ruby guy. I decided for YAML. The reason why I decided for this format is that even if you're not parsing it, you can perfectly read it. So it's not just about writing it down, it's about understanding it. And I guess my opinion, you maybe have another opinion on this, this is really important. Then there's something that every rule in this design rule format has a severity. Because sometimes I just want to remind the engineer that it might not work. Just take it into account. If you accept on it, that's fine. So that's the severity of maybe info or warning. But maybe there's something like my assembly factory tells me to not place heavy parts on the bottom of the PCB because I'm not able to manufacture this. This is an error because that will never ever work. So real world examples now. Could you imagine that maybe Octopart, do you guys know Octopart? That's something like a search engine for parts, but it's a little bit more. You can actually upload your bill of materials to Octopart, and it takes care of organizing this bill of materials. That's pretty handy. Give it a try. So if Octopad would use this format, it could straight away tell us that maybe all the parts should be from a specific distributor, because I have some special discount for this. So if someone of the distributors would like to sponsor this, I could put the name the next time on the slides. Another example is, by the way, this is the actual file format. Another example is I have some ICs on my PCB, and I want to make sure that these ICs are available for the next 2 years. So with these both rules, I make sure that a party, like, as I said, Octopad, can validate this. So we take Octopad, we take our design rules, we take our design, stuff it all together, and get a thumbs up or a thumbs down. Next one. So obviously example, what if maybe KiCad would support the open design rule format? Maybe I could mention Horizon and Libre PCB too. A design rule could look something like this. So for PCBs, it's pretty obvious what these design rules look like. But what I really would like to introduce is the severity, because this really bothers me as a PCB manufacturer, that people always go to the limits, and I tell them, hey, if you want to place 2 tracks within 2 SMD pads, it's fine if you go to the limit, but please don't draw like 5 centimeter tracks with 0.1 millimeters. No, please not. And now, another party. So what if Oshpak or Eisler, like PCB manufacturers in general, would support this format? You would put your PCB drawing in, you would put the design rules in, and then it says, okay, I guarantee you that I'm able to manufacture this, or I just don't manufacture it. So this is something like we're also able to define the stack up, that maybe our PCB manufacturer directly tells us, hey, the stack up which you defined in your design rules just does not match my stack up. So that you upfront know that you did something wrong. So this is something My Assembly Incorporated, something which stands for all the assembly factories around the world. These guys have a pretty hard job, because in the end, with the assembly, we have PCB, we have a stencil, we have part sourcing, we have all that stuff together, and it all comes together. And we have to make sure as the engineers to provide all this information to these guys. And whenever you've designed some electric component, you notice that these guys call you right away if there is something wrong, and they will. And they charge you for it. Keep that in mind. So with the open design rule format, these assembly factories can tell us upfront what they expect. And they expect stuff like, how should our assembly panel look like? You know, thank you, Javier. When you have small PCB, you most of the time panelize it for the assembly line. And the assembly line needs some kind of spacing or rail to put it into the line. So sometimes this is a thing the assembly partner does for you. But if you deliver it wide array, they just can start assembling and mounting all the parts on it. So this is really handy. And maybe you get a discount if you just tell them, hey, I only have SMT components and they are all placed on the top side. So you don't have to mount them on both sides. That might reduce the price. So really strict design rules may lower the price for assembly. One more slide on this. Stencils is something really important, which a lot of people then keep in mind. When you start producing stencil for manufacturing, you don't have a stencil like this size you have something which is much larger with a frame around it. And this frame is something which is specified by the system they use for mounting the stencil. Please ask the manufacturer, which kind of mounting system do you use for your stencils? Type it in the design rule format, and then it checks every time, do you use this frame? So what we have right now is initial support from manufacturers. So we as a PCB manufacturer support this file format and provide templates with all our proposed rules in it. And what I really would like to start off with integrating this format into Gerbv, because what I know is that a lot of us are using Gerbv to checking our Gerbv files. And what if Gerbv could just tell us right away, hey, look out for your track width. And additionally to this, a lot of PCB manufacturers use Gerbv, so that would be pretty handy. So the to-do list, maybe if you guys are looking for something to develop, converters for maybe the Eagle file format would be really handy, because a lot of PCB factories have this file format ready. And if we just convert them over to this file format, that would be a huge increase in popularity. And if you say, I do electronic manufacturing and I want my customers to take care of whatever, just hit me and we will add this. So that's everything about the open design rule format. And thanks for your attention. Go on. Questions?
Tom? I noticed that the file format you propose is very, well, at least judging from the example, is very manufacturing oriented. What about typical design rules, especially more complex ones, concerning the topology of routing, signal integrity, different clearances for different parts, regions in the board? I'm asking because after the V5 of Cadence is out, we are planning to do a big overhaul of the design rule management system. And what you just proposed looks like a good candidate for the rule description format.
I will repeat the question. So the question was, I saw from the end that this is a good candidate for KiCad, maybe.
You should go to politics.
So the question was, this format is obviously really manufacturing related. Did you take into account that there is much more about the design itself, which you can check? The reason that it is manufacturing related is that we actually do electronic manufacturing, so I'm a little bit biased on this, and I would be happy to take this into account. What is really important is that it's more about how the design rules are structured, not about what are the design rules. What, for example, KiCad would have to deliver is something like there are, within the rule set, there is this name, and KiCad would have to provide this value so that we can check against that. But this file format is really general. So in the beginning, I got some critics about, hey, you define a file format which is kind of interesting, but how does it actually work? You have to define the rules yourself, and then it works. Because I guess there is no way to find something which really applies to all of us. Next one. Yeah.
Do you have an idea, sorry, just one more. Do you have any idea how to implement more complex queries? Because here, for instance, you have a clearance track-to-track rule that applies to all the tracks on every single layer on the board. How, for instance, to declare per layer clearance, per board area clearance? Because this needs to be specified in the file format.
So clearance is no issue at all.
Of course it is.
No. I mean, to define a clearance is not an issue because it just applies to the whole board. I have an example for the clearance.
For instance, imagine you have some board that contains a high voltage power supply
Mm.
and some digital control electronics. You'd rather have probably small clearances in the digital part and pretty big ones on the high voltage part.
This is important for the.
Checker must take that into account.
That's totally correct, but it does not apply for the manufacturing. For the manufacturing, I just don't care how many voltage there is on. Maybe the idea is to take this as the foundation and then add some more like design EDA related stuff on top of it.
But you do care on outer versus inner layers. You have different clearances. So that's the same thing. How do you specify that?
That's totally correct. So the question was how to define clearance between different signals. Right now there is no such way because from a manufacturing perspective it doesn't matter which signal it is actually. But we can elaborate on this later. That's why I called it a proposal. Yeah. So.
You then, Wayne.
So what about storing the feedback from the user? Like, for example, you have your window and you would, as a manufacturer, want the width to be bigger than a certain value. But maybe on some parts, like I had a scenario a lot of times where I had some footprints where this footprint that's very close together paths. Like, there's no way around it for a user. So I imagine in your perfect world where Kika and Eisler and everything supports your format, and then I as a user in Kika have to say like, oh yeah, in this part ignore the warning. And in Gerbv I also see the same warning, and on your thing I have the same warning. Would
Yeah.
your tool support something that allows me to tell me like, oh yeah, maybe for this region or this signal or whatever, just ignore it.
So the question was, could this file format also be used as kind of communication or way of communicating the issues? Never actually thought about that, but that's a pretty cool idea if we go like ping pong with this file. Yeah.
But adding these warnings, they could also be a very negative thing if they pop up everywhere. Like if you have a very strict rule, I mean, you have to use it. There's no way to manufacture it. But if you have these warning level things, there should be a way to ignore them on different levels.
Yeah.
Okay,
And
last one, Wayne.
Just one comment, Tom. I just think there's a difference between board layout. We could do per net clearances and keep that, right? But those aren't what the manufacturers. He's talking about manufacturing. Clear, you know, when you go to a courthouse, you know, there's guys who can do really high accuracy stuff.
Yeah.
There's courthouses that can't, depending on the equipment they have. I think that's where the difference between two. I do have one quick question for you.
Yeah.
Have you seen the Camco job, what they're calling the Gerbv job file format? It's not this specific, but it does include a lot of things for manufacturers like dielectric, between layers, dielectric. You can define those things and then dump them out to a file to send to your board format house. But have you seen it?
the question is, have I seen the Ucamco Gerbv job file description format? No, but I noticed that it gets quite popular as even Autodesk Eagle with the new 8.6 release outputs this this Gerbv file description format. But it's limited to PCB production, which is fine. I don't want to criticize this. I should have taken a look at it. Really.
You might want to take a look at it, because the problem is we duplicate that. So now we got to generate a Gerbv job file, and we got to deal with duplicate information. You see, especially given the fact that Camco is the owner of the Gerbv standard, they carry a lot of weight in the industry. So, you know, while I agree that this is a good idea, I'm just know what I know about the plate players in this world,
Yeah.
you're gonna have to overcome some inertia.
But asking you, Camco, is a pretty good idea. As you said, they are a big player and all that CAM output format stuff.
File formats still want
Yeah.
to use and you can comment on it too.
Okay.
Totally. Thank you, Javier.
Can